Alright guys, so this should be the packet that you guys have in front of you. I'm going to be going through like I would if I was standing up there, if I was there, and you guys need to be following along, writing your notes, so then you can practice at the end of this video. So, from yesterday, those of you that got to this part, we are talking about greatest common factors. Now, bear with me, my pen that I have to work with does not work very well. So I kind of have to write really big, or it turns out looking kind of ugly, so just bear with me. So when we talk about a greatest common factor, we can call that the largest positive integer that divides into another integer evenly, okay? So let's go ahead and write a definition. So it is the largest factor or number that divides evenly into another. So let's think of an example. But I want you guys to go ahead and underline largest. Another, I can't even spell. Go ahead and fix that. So for example, the greatest common factor I want to think of between 8 and 12. So we want to know what is the biggest number that divides evenly into 8 and 12. So if you look at that, you probably first popped into your head 2. 2, yeah, they're both even, so 2 definitely divides into both of those, but we've got to think of the largest number, okay? So the greatest common factor is actually going to be 4. So 4 is the largest number that divides evenly into both of those, okay? So what we need to go into is how can we use what we know about GCF to simplify expressions. So in part 3, we're going to actually be factoring out GCFs and getting into smaller expressions, okay? What we are going to be doing is we're getting into factoring. So we talked about quadratics with a degree of 2. So now, in order to factor or to solve for these, we really need to use the greatest common factor if we can, okay? We use that to simplify and break it down into smaller parts that we can solve. So, let me go ahead and write that. That did not look beautiful. I'm telling you guys, this pen that I have, not a good one. But we're going to work with it because that's all I got. Break down an expression into smaller factors. So hopefully we can get to where we can solve, okay? So I want you guys to scroll down. So here, we are looking at expressions, okay? Now what I want you to know is that it's not always just a number. In this case, maybe it will be, but we want to look at the variables as well. So if we have two parts of an expression, or terms, so looking at part A, 2x and 4 are two different terms or that make up an expression, okay? So we have to look at both of these things. Now, say for instance they both had an x. That would be a factor that they have in common, okay? A greatest common factor. But here, 2 has an x, 4 does not, so x is just going to stay when we simplify it, okay? So if we think about it, what's the greatest common factor that goes into 2 and 4? Obviously 2 goes into 2 and 2 goes into 4. So 2 is our greatest common factor. So we go ahead and pull him out. When we bring out the greatest common factor, we get a simpler form that we need to leave that we multiply times that greatest common factor. So what you essentially are doing, is I'm going to do it over here, is I will do 2x divided by 2, and 4 divided by 2. So I'm saying that both of these terms in my expression are divisible by 2. So 2x divided by 2 would just leave me with an x. 4 divided by 2 would leave me with a 2. So 2, my greatest common factor, and x plus 2 are two factors that give me the product of 2x plus 4. Okay? The reason I wrote that is our greatest common factor doesn't go anywhere. Okay? We bring him out to the front, and it made our expression a smaller one and left me with x plus 2. But I've got to be able to multiply those back out or distribute and get what I started with. Okay? I should. 2 times x would give me 2x, I'm sorry, and 2 times 2 would give me 4. Okay? So the next one, now let's go ahead and look at the other one. I'm not going to do all of these, I just want to do a couple so you guys kind of get the gist of it, or the gist of it. So 6f minus 38. Okay, this one's a little bit harder. So take a second, think about it. I want you guys to write it down. Don't just wait for me to then eventually write it down, because you know I'm going to. But take a second and write down what you think is going to be the greatest common factor between 38 and 6, okay? So take a second, write it down. Think what would be left over once you have it. Did you think about it? Alright, so I always like to start with 2. If I divide both of these factors by 2, neither of them have an f in common, so it's just going to be 2. That would, I'd take my greatest common factor out. That would leave me with a 3f minus a 19. Now, you will know if you do not pick out the greatest common factor if you could still simplify. Now, looking at 3f minus 19, there's nothing else that I can actually simplify those, so that would be my answer. I have simplified, I have taken out or factored out the greatest common factor, okay? Now, looking at h, I, j, k, L, E, and F, those are all our quadratic functions because they all have a degree of 2. We are going to be getting into factoring because that leads us into solving. These are not like those linear functions where you could just get everything away from x and solve for it. Here we're going to have to factor or break it down into different parts to solve for x, okay? With these quadratics, they have a degree of 2, so that means they don't just have one solution, but they have 2. So looking at h, I need to look at 4x squared minus 12x minus 8. Now there's 3 factors. So what is the greatest common factor that goes into all of those? 2, obviously, but think a little bit more. What also would go in? Because I know 4 goes into 4, 4 goes into 12, and 4 goes into 8. So if I bring a 4 out, that would leave me with 1x squared. 4 divided by 4 would leave me with 1x squared minus 3x, because technically that's a negative 12 and I'm dividing it by 4, and minus 2, okay? Sorry, this pen really is not working. So if I simplify, this should give me 4x squared minus 3x minus 2 times 4. If I multiply that through, that should give me what I started with, okay? I want you guys to pause the video, work through all of these, and try to see if you can take out the greatest common factor, okay? I'm going to come back and do F. Actually, I'm going to do E when I come back. So go ahead and pause the video, work through all of these, see if you can take out the greatest common factor. When I get back on Wednesday, we will check all of these answers, okay? Alright, hopefully you actually listened to me and you paused the video. So looking at E, I am going to take the greatest common factor of 8 and 14 and x squared and x. I kind of like to think of in like terms, right? I can only look at the greatest common factor between the numbers or the coefficients and the x's. So let's start with the x. There's an x squared and an x. I can for sure take out 1x and have something left over, right? If I take an x out of an x squared, I'm going to have 1x left over. If I take an x divided by an x, I'm just going to be left with 1. And now talking about the number, 2 is really the only number that goes into both of those, okay? And that would leave me with 4x, because when I take an x squared and I take that x out too, it can leave me with 1 plus 7. Okay? So I want you guys to look on number 4. Create your own example of an expression that has a GCF and simplify it by factoring. Think of any two numbers, throw a variable in there, and see if you can figure it out, okay? Now, this video should be kind of quick, but looking down here we have factors. So, factors are numbers or variables we can multiply to get a number, another number. So, we multiply to get another. So for instance, 2 times 3 is equal to 6. 2 and 3 are the factors and 6 is the product. It is basically the answer we get when we multiply. Okay, so 2 times 3 are my factors and 6 is my product. Okay, I want you guys in part 5, you know we have calculators, we have calculators, but highlighters in the class. I want you to grab some highlighters, and once you've gone, I want you to go up and highlight and underline the factors and underline the product of each of those problems, okay? Once you've done that, you can go ahead and flip over to the next page. This is the last one that I'm really going to look at notes. Then I want you guys to work on the page that I will circle after this, okay? So here, we have our steps of how to find the greatest common factor. So, find the GCF of each. Let's looking at this first one. So 2x squared minus 4x. Now, I see numbers they have in common and variables. They both have an x. One has 2 x's and one has 1, but I can for sure take out 1x from both of those. And looking at the numbers between 2 and 4, 2 is the greatest common factor that will divide evenly into both. 4 wouldn't divide evenly into 2, but 2 can divide evenly into 4, okay? So if I do that, what it's saying is I'm taking each of those terms and dividing it by my greatest common factor of 2x, okay? So 2x squared divided by 2x. 2 divided by 2 is 1. I have an x squared and I take away an x, and that's just going to leave me with an x. And then 4x minus negative 4x divided by 2x is going to leave me with a negative 2. The x divided by an x is just going to give me 1. So my final answer would be 2x times x minus 2. Down here, same thing. They both have an x in common and a 3, okay? So if I divide each of those terms by 3x, I will be left with, try to see if you can pause and think. Always write your greatest common factor on the outside. Once I've divided those, I will be left with x plus 2. So 3x times x plus 2 are the factors that multiply together to give me what we started with, that 3x squared plus 6x, okay? I want you guys to scroll a couple pages. You can try this worksheet. I want you to make sure you try this one, and I want you to flip 2 more pages, and on this one you have 2 pages. I want you to try all of the greatest common factors on this one and this one. I will be checking these 2 pages for a grade, so make sure you do them, okay? Rewatch the video, try them yourselves. You can also Google as well, okay? We'll go over it together when I get back. Good luck.